So let's see the part 3 of some basic concept of organic chemistry. Some basic concept of organic chemistry. Right. See, so this topic will be based on isomerism, electron displacement effect. So first see the first question. It is asked in 2021. Right. So the compound which show metamerism. Metamerism. Right. So metamerism is nothing but same molecular formula, but different structure. It is asked in 2021. So let's see. So metamerism is a type of position isomerism. So it is also a type of position isomerism. So functional group can be shifted. Position isomerism, which is shown by the divalent species. So it is shown by mostly divalent, right, species like ether. So who show metamerism? Basically ether. So ether general formula is ROR, right? So this R and this R should be can be same or it can be different. So when it is equal, then it is your symmetrical ether, right? And when it is not equal to R2, then it is unsymmetrical ether, right? So this is the first compound name. Next is thioether. Next is thioether, right? So thioether is nothing but it is RSR. So this is thioether. Next one is ketone. Next one is ketone. So ketone general formula is RC double bond O R. So this R and this R can be different or can be same. Next one is 2-degree amine. Next is 2-degree amine. So 2R group is attached with this. So this can be symmetrical or unsymmetrical. So these are the 4 compounds which show the metamerism, right? So see the first option. So I will explain it. So let's see on the next page. So first option is given like C4H10O, right? So we'll have different alkyl group, right? So make the structure of that. So 4 carbons are there. So I will write here O. It will be CH2, CH3. It will be CH2, CH3. So you can just observe 4 carbons are given here, right? So this is the first structure of this one. So this comes under the functional group of ether. So this is the first member. Second can be like this. I will write left on left 1 carbon and rest of on the right hand. So it will be CH2, CH2, CH3. So you can see, however, it is showing 4 carbon, right? Now see the third. It can be in the branching also like CH3, O, C, H, here CH3, here CH3. So this is the also metamerism of that compound, right? Now see the second option. Second option is, it is given like C5H12. So there is no O, right? And it is coming from alkane family. So alkane doesn't show metamerism, right? Here doesn't show metamerism, right? For showing metamerism, I have explained the 4 compounds, right? So it was not there, right? So next one is, next option is like C3H8O, C option. So you can see the arrangement now. So it is CH3O, CH2, CH3, right? So if you take these 2 compound on left hand side, then it will be CH3, CH2O, CH3, right? So these are the same compounds. So it is not showing the metamerism. These are two are same. Next one is D. So it is C3H6O, right? So this can be CH3, C double bond O, CH3, right? So it is coming out in the ketonic form, right? Ketone. So only one arrangement is possible. So your answer will be the first, right? Because they are showing the maximum three isomerism, three isomerism of the type metamerism. So please write all explanation. Now see the second sum, that is which of the following is correct with respect to minus I effect, right? Minus I effect. Inductive effect which should be negative, which means it should draw the electron. And R is your alkyl group. It is asked in 2018. So see the explanation now. So minus I effect increases on increase in electronegativity. So it increases on increasing electronegativity of atom. So its correct order will be like NH2, OR and F, right? So fluorine is more electronegative, right? Electronegative atom. So as we know, group 17 contains fluorine, chlorine, bromine, iodine. So this is the most electronegative atom, and down the group it decreases. Electronegativity decreases. So this is the order of that. Right. So most appropriate answer is C. So you can see option. So this belongs to the C group. Right. Now see the third one. Which one of the following molecule can exhibit tautomerism? So it is asking about the tautomerism. So see what is tautomerism first. Tautomerism. So see when tautomerism means like C double bond O, H is there. So this can be shifted like this also. C, O, H and double bond can be here also. So there is, suppose this is C. Again, C bond is there, right? So what I have done, I have shifted here H and taken this double bond here, right? So this is called ketone and enol form. Enol form. Wait for a second. Okay. Now see, tautomerism is shown by ketone and enol form, right? So, so these conditions should be satisfied. So next see, so there is compound alpha hydrogenate bridge carbon. So I will draw the structure first. So this is your structure given to you, and there is branching like this, right? So this carbon is double bond O, and this is your H, right? So this pi bond can be shifted here due to the more electronegative atom of oxygen, right? And hydrogen is shifted here. So this is in now ketone form, right? Or it is also called keto form, right? And this is the structure which we are modifying it, right? So H will be coming here, then it will become like this. So it will become OH, right? Alcoholic group. It is also called as enol form. It is also called as enol form, right? So this is shown by, this is showing tautomerism, and rest of the compounds are not showing, right? So your third option is correct. So this is the answer. Please write it down. And write the one more important point note here. So there is alpha hydrogen is there, right? So alpha hydrogen at bridge carbon never participates in tautomerism. Thus only third exhibits show the tautomerism, right? So option will be third. So there is more two options are given like this, right? But bridge is given, double bond is here, right? And this is the first option. This comes under the third option. So third option is correct. So this will not show the tautomerism, right? So bridge is not showing that ketonic group. So next one is like this. So here double bond is there, no H is there. So this is not showing tautomerism. Now see the question number 4 for the reaction like given. So reactions are given like first option is CH3, CH2, CH2, Br plus KOH. So when potassium hydroxide is there, so please mind this question, very important. It is always asked. So when alcoholic OH there, so what it does, it removes the alkyl group. Remove alkyl halide group from the compound. So see here, alkyl halide means RX. R for alkyl, X for halides. So it can be like CH3, Br or Rx. So you can see here in the compound given, Br is there and H is there. So this can be written in the form like this, CH3, CH, H, here H, here I will write Br and here H. I have shifted here, right? So potassium hydroxide, what it does? Potassium hydroxide, KOH is there, right? So it will remove this halide, or it is also called hydrogen halide. Hydrogen halide, right? So hydrogen is fixed and halide can be different. So after removing this, we are getting here double bond. So Br will form this minus, right? Due to 7 electrons in the last orbits, right? So it is more electronegative. So carbon will become plus. Now, as we know, hydrogen having 1 electron, so it will form plus, and this carbon will form minus. So your compound will be like this. So this is your plus, this is your minus. So it will form the double bond, right? So what ultimately form? It forms the alkene after removal, right? After removal of hydrogen halide, it forms alkene. So this is the answer. So you can observe in the previous slide there, right? So all are single bond, right? So it is forming what? Single bond, right? Single bond means saturated compound. Single bond is also called as saturated compound. So it is converted into double bond, right? So double bond is called unsaturated hydrocarbon. Unsaturated hydrocarbon. So you can see it is forming alkene from alkane, right? Now see the next part. So this name of this reaction can be given like elimination reaction. Elimination reaction. We are removing hydrogen halides, right? That's why. Now see the next compound is like this given B option. So B option is CH3, C, CH3, here Br plus KOH. So it is forming like alcoholic OH, right? So product is also given. So what it is doing? It is doing substitution reaction. So it is K plus OH minus, right? This is your Br minus. Why? 7 electrons in the halides group, right? 2, 4, 6, 7. So it will form minus and this will form plus. So this plus will attract this OH minus and Br will go with this Kr. So your answer is given CH3, OH, CH3, right? Plus KBr forming potassium bromide. So this is called substitution reaction. Substitution reaction, right? Now see the third option. Third option is cyclohexene is given, double bond. Cyclohexene in for double bond. When it react with bromine Br2, what is forming? One bromine is coming out here and one is coming out here. So it will form like this. Br, Br, right? So this is double bond. So addition of bromine compound is there, right? So it is also called as addition reaction. Addition reaction. So which of the following statement is correct? So now I have explained ABC. So please read the options. So A is elimination and B are substitution reaction. Fourth, no, that is wrong now. First one is elimination, second is substitution, third one is addition, right? So first is incorrect. So it should be first is elimination showing, second is substitution, and third one is addition. So find this order. So you'll get in D, right? So D option is there. Now see the question number 5th. Number of a structural isomerism possible from the molecular formula C3H9N, right? So this is your molecular formula given to you, right? So you can draw the structure like this. So 3 carbons are there, 1, 2, 3, and 3 nitrogen is there. So I will write here N. Now give hydrogen to each. So it will be CH3, this will be CH2, this will be CH2, and this will be NH2. So how many hydrogens are there? Count it. So 3 plus 2 plus 2 plus 2. So total 3 plus 6, that is 9, right? So this is the correct structure. Now we have got written primary amine. Primary amine. So how primary amine look like? It is RNH2. So this is the general formula. So for primary amine, NH2 group will be on the extreme position, right? And this is your alkyl group, methane prop. So it is your propyl amine, right? So now you can draw the secondary amine also. So here N will be there, right, on second carbon. So it will be CH, CH3, CH3. So it is CH3, CH, CH3, or it will be NH2, right? So this is the on the nitrogen attached with the second carbon. So it is your secondary amine, secondary amine, right? Now see the next. So it can be like this also. CH3, CH2 in CH3H. So here it is 2-degree amine. Next is also possible like CH3 in CH3 CH3. So this structure is also possible. So how many structure we have drawn? 1, 2, 3, 4. So these are the 4 structure drawn to it. So option is 4, right? For the fifth one. So answer is 4. It is asked in 2015. Please draw all the structure. Now see the question number 6. Which of the following statement is not correct for the nucleophile? Nucleophile it is talking about. So look at the sixth one. Sixth one, nucleophiles are electron-rich species, right? So nucleophile, right, which is having more number of electrons. It is also called as electron-rich species, right? And which acts as a Lewis base, which acts as Lewis base, not acid, right? Not acid. So first option is given like acid, right? So first option is your answer. Now see the next sum, 7. Which is the most reactive towards nucleophilic addition reaction? So we have to find the most reactive towards nucleophilic addition reaction. Nucleophilic addition reaction. Right. So see here, electron withdrawing group are more reactivity towards nucleophilic addition reaction. So this statement is very important. So write it down. So it is electron withdrawing group, which attracts the electron towards itself, that is called electron withdrawing group. It comes under like minus I minus M. Group are more electronegative, are more reactive towards nucleophilic addition reaction. Towards nucleophilic addition reaction. Right. So next will be, so you can see the electron withdrawing group. I will draw the structure. So this is the structure. First compound, it is attached with CHO and NO2. So both of these are electron withdrawing group. Minus I, electron withdrawing group. So this will be the first reference given to it. Next one is CHO. Next one is benzene. So first is this one. This is your second. Third will be like this. One is electron withdrawing group. This is minus, right? This is also minus. But here CH3 is given. So it is plus R effect. It is showing. Next one is C double bond O. CH3 is there, right? So it is showing minus and minus M also. And this is showing plus I effect and it is coming minus I. Right. So these are the preference given to it. So please write it down. It is asked in 2014.